Welcome to our YouTube channel once more. Today I'll be tackling functions, specifically parabolic functions. So the two forms of equations that you should know when it comes to parabolic functions is f of x equal to ax squared plus bx plus c, as well as the second one, which is f of x equal to a into x minus p all squared plus q. So when you sketch parabolic functions, the three aspects that you have to understand before you successfully sketch your function are these. The first one is your shape. When a is greater than 0, you have a smiley shape. When a is less than 0, you have a sad face. Now the second aspect you need to basically determine, it's your intercepts. Intercepts are basically points where your function basically cuts the x-axis in terms of the x-intercept, as well as the y-axis in terms of the y-intercept. The last aspect is determining the coordinates of your turning point, and that will be it. That should give you points we should connect to plot your function. So let's start with this example. In this example, if we are required to sketch this function, we start by, first we determine our shape. So the coefficient of x squared is 1, which is positive. So we simply know that we are going to have a smiley. Now in this case, we start now by calculating our intercepts. We say 4x int. We let y equal to 0. Y in this case is f of x. Therefore, when we calculate, we therefore have x squared minus 2x minus 3, which should be equal to 0. And therefore determine the factors of 3, of which when you add them, you get 2. In this case, we have only 3 times 1. So therefore, we are going to factorize this expression as x. The bigger factor has to occupy the sign of the middle term, since the last term is negative. So we have negative 3. We also have x plus 1, which should be equal to 0. Therefore, x should be equal to 3, or x should be equal to minus 1. So therefore, these are our x-intercepts. It means our graph cuts the x-axis at 3 as well as minus 1. Therefore, for your y-intercept, you simply say for y-int, you say let your x equal to 0 for the y-intercept, and therefore this implies that f of 0 will be equal to, where you see x, it simply means you substitute your 0. So we have 0 all squared minus 2 times 0, and then minus 3. Therefore, when you punch your calculator, 0 squared is 0, minus 2 times 0, which is 0. We have minus 3 as the final answer. So this simply means our y-intercept, or where our graph basically cuts the y-axis, it's at minus 3. Now the last aspect, for turning point, we could say therefore TP, we have TP, which is made up of the x-coordinate as well as the y-coordinate, given by the formula minus b all over 2a. The y-coordinate is given by 4ac minus b squared all over 4a. Now let's do this simple calculation. Let's start by substituting. When we substitute, we get, in this case, it's going to be, we have minus our b, the coefficient of x, we have minus 2 all over, and then the coefficient of x squared, which is a, our a is equal to 1. That's for the x coordinate. Now coming for the y coordinate, we substitute. We have 4a is 1, our c is equal to minus 3, then minus b is minus 2, we have minus 2 all squared all over now 4, and then a is 1. Now let's determine the final answer for this. In this case, we are going to have now Minus into minus 2, we basically have 2 all over 2 times 1, which is 2. Therefore, the x coordinate of our function is 1. Now, after you've determined the x coordinate of your turning point, you may also use this x value, should you not basically not use this y coordinate formula. You may substitute the x value in your original function and you will get the same y coordinate. So in this case, let's start by determining the y coordinate. We have 4 times 1, which is 4, and then 4 times minus 3 is minus 12. And therefore, minus 12, when we now determine this part, we have negative, and then minus 2 squared is basically 4. We have minus 12 in this case, minus 12, and we also have minus 4. This basically gives us minus 16. Minus 16 divided by 4, then we basically get minus 4. So our turning point is basically at 1 is 2 minus 4. So the last part where you have to now sketch your function, let's do so. When we sketch our function is going to appear like so. Label your x-axis as well as your y, and your x-intercepts are at 3 and minus 1. I have 1, 2, 3, minus 1, minus 2, minus 3. What about the turning point and the y-intercept? We have our y-intercept at minus 3. We have 1, 2, 3, and then the turning point is at minus 4. We have minus 4 for the y coordinate of the turning point. We also have minus 3, minus 2, minus 1. Let me just say 1. We're not going to need anything above the x-axis, so let's actually focus. Plot all your points. They'll give you dots which will connect to the shape of the function that you're looking for. So I have x equal to 3. Plot at x equal to 3. Put your dot. The second x-intercept is also at minus 1. What about the y-intercept? Y-intercept is at minus 3. Now, understand that when it comes to the turning point, you have a coordinate. So you have to map two coordinates, the x and the y. So the x coordinate, we have 1. So let's just do this for the x coordinate. And the y coordinate, we have minus 4. We do this for the y coordinate. And therefore, guess what? You must be having dots which guide you towards the shape of your function. In this case, we said our a is greater than 0. Therefore, we should be having a smiley shape. So check, your function tends here, meaning it has the minimum value at minus 4. So therefore, it simply means if I have to sketch this function, it will appear like so. And this would be your final function. I hope everything makes sense and hope to see you in the next one for more examples on parabolic function. This is the first lesson. Check you out. Thank you.